Right. Hello, everyone. Hello, everyone. Welcome to the first technical session in this fall 22 cohort brought to you by Hamoye. Hamoye is an ed-tech startup with a mission to prepare young professionals and college students for their choice careers in data and the future of work. We do that via our internship programs, which simulate the conditions you will face while working in a real work environment. Our internships will expose you to specially designed courses, career coaching webinars, and with industry experts and industry relevant project presentation like what we are having right now. My name is Mercy, and I am an editor at Amuye. I'm joining you from Ibadan, Nigeria, and I will be your host for today's session. I'd like to welcome to this event everyone present, our incredible interns in this Amuye cohort, this fall cohort. Kudos to you all for making it this far into the internship. Thanks to the Amuye Fellows and the Amuye team who have made this session possible. For this session, we have an industry expert, Mr. Biodun Awojobi. Biodun Awojobi is a PhD holder and has been in the information technology industry for over 15 years. He received his MBA and Master of Science in cybersecurity from the University of Dallas, and also bagged a Bachelor of Science degree in electronic and computer engineering from the Lagos State University, Nigeria. Biodun has worked in multiple IT software, networking, and security roles across several industries over the years. He currently leads a team of customer engineers focused on infrastructure, application modernization, data analytics, AI, ML, and security from the Google Cloud platform. He will be sharing his thoughts and experience on the topic, finding the data scientist in you. But before I hand over to Mr. Biodun, please carefully take note of the following. Feel free to post your questions and comments on slido.com using the event code hashtag 3032913. I would read that out again, hashtag 3032913, and they will be promptly attended to. Also, a Google form has just been opened to collate attendance for this HDSC Fall 22. You were all intimated via email and Slack that we are going to take an attendance for this typical session. So you are to use the secret code Python, all lowercase, Python, 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 all lowercase. And the form link would be sent to you now on Zoom, on Slack, on
Your audio has an issue. I don't know if you want to fix that, but I stopped hearing you.
Okay. Can you hear me now, or is it still having a...
It's a lot lower than you started with.
It's lower. Wow. Okay. Okay. Christian, are you there? Hello, can you hear me now? Am I loud enough now?
It's a bit better, but not at the pace you started with. But yeah, I think it's a bit better.
All right, yeah. Maybe I would increase my volume a little bit more. And shift the laptop a little bit more to me. Okay. The form will be open for only 10 minutes starting now. Can you all hear me, please? If anyone can hear me, let me know if you can hear me.
Yes, we can hear you. We can hear you.
Yes, we can.
We have pinned the first attendance form on YouTube, guys, Zoom, and Slack on the announcements channel on Slack. Please, we want you to fill your form quickly in order to focus on the presentation. All right. Over to you, Biodun. Thank you very much.
All right, very good.
Yeah.
I'll share my screen shortly, and good morning, good afternoon, and good evening, wherever you may be joining from. Just a tiny second.
Biodun, is there a problem? You're muted. No, you're muted. We can't hear you.
All right.
Wow.
Can you hear me now?
Yes, we can hear you now.
Yes, we can.
Okay, so when I shared my screen initially, it said my microphone was disabled. So yeah, I think that's been resolved. Again, good morning, afternoon, and evening, wherever you may be joining from. My name is Biodun Awojobi. I'll run through what the agenda for today's conversation or discussion is about, and I really look forward to getting to share my knowledge with you all and kind of learn from you all from the questions that you ask. I hope you enjoy the session, and I'm really privileged to get to talk to you all. All right, let's take to the next step. All right, so here's how we're going to run today's session. We're going to start out with a brief bio, and we'll do a data science trivia, just a bunch of questions to understand where you guys are or where you all are with regards to data science. And then we'll talk about like data science, what is data science, the responsibilities of or basic responsibilities of a data scientist. I understand that you all are in different phases of your data science journey. You might be a data visualization expert. You may be an expert at modeling, but we'll try to all wrap it up all under the umbrella of data science. The next portion we'll cover will be around like what the typical data science or machine learning workflow is. This is more of an update from one of the sessions that I had with the Amoye team a while back. And I want to talk a little bit about diversity in data science and why it matters, why it's so important for you all to continue in this data science journey, and why I am so proud of you all for sticking with this and how profiting it will be for you all in the future. All right, so I know that my bio has been gone through already, but for folks that were not on the call or just joining or they didn't hear the bio for technical issues, here's a little bit of history about me. So I was born in Lagos, Nigeria. I moved to the US in 2011 and I've been living in Dallas since then. So Dallas, Texas in the United States. I've been here since 2011, so it's coming close to 11 years now. I lead a specialist team, a customer engineering specialist team that's focused in AI, ML, in data analytics, infrastructure, and security. I'm an adjunct professor at the University of Dallas. I've been an adjunct professor at the University of Dallas for about 4 years. And I'm also an adjunct professor for data science at the University of North Texas. At the University of Dallas, I'm an adjunct professor for cybersecurity. Things that I like to do, I enjoy sports, I like soccer, I read, I like reading a lot. It's all about continuous learning, enjoy traveling, and I like writing as well. All right, so let's start out with our trivia. So the first question, and I understand that you all may not be able to unmute, but you could probably type in the chat if possible. Paul, the dash, was an animal that became famous in 2010 for accurately predicting the outcomes of the 2010 World Cup. What species was Paul? Yeah, you all probably know this. The answer is correct. Paul was the octopus. Well, right, the whole idea of Paul right there is just like how do you gather so much data and how can you use data to predict based on certain set of data sets or decisions that you could make. And we'll talk a little bit about that in the next few slides. Second question, what is the most basic need of data science? Is it move and store? Is it explore and transform? Is it collect or is it learn and optimize? Well, there actually is only one answer here. So I'm going to pause a little bit and ask, is it move, store, explore, transform, collect, or learn, optimize? Well, the most basic need is collect. There's so much you can do with data that exists today, and there's so much more you could do with fresh data that hasn't been collected or that's just being collected. And so collect is like the most basic need. That's where you start from. But my third question, which is not a tool for statistical data analysis? ANOVA, logistic regression, histogram. I'm going to pause for a little bit and watch some of the responses. Okay. The answer to this question is histogram. ANOVA is a statistical data analysis tool. Logistic regression is a statistic data analysis tool. Histogram is just a visualization tool. So you can visualize the data you have with the histogram. And my final question, shopping recommendations on Amazon and Google Shopping is an example of, is it AI or is it ML? Yes, I know that you all will have a debate around this, but it really is AI. The machine learning model, the AI engine, or well, the AI that's up in play here is referencing some machine learning models. So specific to like companies like Google Cloud, recommendations are being created using AI solutions called recommendations AI, where you could load all of your pictures of, say, for example, you wanted to buy shampoo, but you know that when you buy shampoo, you probably need a shower cap as well, because once you shampoo your hair, you might decide to cover your hair up. So in that type of situation, a recommendations AI will suggest to the shopper of the shampoo that you might want to cover your hair. All right, just to summarize, the answer to the first question is octopus. To the second question is collect. Collect is the basic need. Is like the first step. You want to collect data. And then the answer to the third question is, can you all see my screen, by the way? Yes. Okay, because I'm seeing some. Okay, yeah, because I can see a different thing on my screen, so I was just wondering. And the answer to the third question is histogram. Histogram, because logistic regression and ANOVA are statistical data analysis tools. Question 4, the answer to question 4 is AI. It is AI. There's a machine learning model that's doing the work, but it's AI that's making those recommendations. All right. Okay, so I wanted to start the whole finding the data scientist in you by just giving a definition, more of an internet definition, really not my definition. I got this from Tech Target. So who is a data science? Like a data science, or what is data science actually? Data science is the field of applying advanced analytics techniques and scientific principles to extract valuable information from data for business decision making, strategic planning, and many other uses. Many other uses like financial gains or even security. There's so many things you could do, but the starting point is having data. A lot of you all are in the Hamoye program to get a basic understanding of data. You're going to have some of you who will be Tableau experts or some type of data visualization tool experts like Power BI or Data Studio Looker. There are a bunch of data visualization tools that you may get to use. Some of you all are going to be like data engineers that are specialists in building models. I have a strong bias for seeing a lot of a lot of us in folks in Africa be more interested in creating data models, because this is an area where there's so much need. You have all this bunch of data, all this bunch of data that exists, some that have been collected, some that haven't. But you understand how the world works or how your community works today. And if you have an interest in showing or teaching the computer how decisions are made in your society, you have an influence in creating models that will return outputs or outcomes that are representative of what's in your world. So a role of a data engineer in that case would be writing that code that creates the framework or adds to the framework that already exists in terms of creating models. And then you have other folks who are like just experts at cleaning data. You look at data, you can see what business problem you're trying to solve and connecting all of those business problems together. I found this chart, and these three circles all placed on top of each other, and I feel like this is probably a lot more representative of what the data science role truly entails. There's some knowledge of math that's required, but if you don't know math that well, you don't have to worry. There's some knowledge of computer science that's required, but if you're not the best at it, you don't have to worry. But there are also some type of business knowledge or domain knowledge. And when I say domain knowledge, I mean there's some folks who are so skilled at cleaning, as an example. There are some folks who are so skilled who, like, your first degree is in medicine. There are some that their first degree is in fitness. These are like domain knowledge, things that you understand how physics work, or you understand how fitness works, or you understand how making wood works. These are domain knowledge that you can bring in to solve specific business problem in the field of data science. This whole chart is to kind of explain to you all that while you may not be an expert at math and statistics, while you may not be an expert at computer science and IT or coding, you need to eventually learn some of it. But your domain knowledge is enough for you to get encouraged to continue your data science journey. Because your domain knowledge you might just provide that extra angle that no one else is thinking about. When you combine computer science or IT skills, when you combine your math knowledge, and then you add your domain knowledge to it, you become a data scientist. When you combine computer science and math knowledge, you can find yourself in a machine learning world. So being able to write the code and understand how things work and getting some domain knowledge from domain experts can make you a machine learning type engineer. Being able to do mathematical research, and being able to combine that with your domain knowledge can put you in the space of the data scientist that's more leaning towards doing research work. And there are some that will just be do software development, creating software that harnesses data. But at the core of all of this, you find data science. All right. When we think a little bit further and try to connect like the basic responsibilities of a data scientist, I'm going to touch on about two of this so we could move on to other aspects. At the start, it's gathering data. Just gathering and preparing relevant data to use analytics on the application. So a few years ago, when I completed while I was in my PhD program, I needed to collect data from some university students, which required approvals. I also needed to collect data from LinkedIn participants, users that are on the internet that are working and have some idea regarding the data that I wanted to collect, specific to cloud or voice-based assistants. I knew that the first step I needed to do was collecting the data, but then I needed to specify the type of data that I wanted. Is this going to be a Likert scale, with a Likert scale meaning from strongly agree to agree? And how am I going to represent that? Am I going to represent that from 5 to 1 or from 0 to 5? Is it going to be data around demographics? And how am I going to represent that? How am I going to code that correctly? And what kind of data set am I going to be adding to enrich that particular data set? And can I ensure that I have enough data to answer the questions that I'm looking to answer? And can I also ensure that I have enough data that someone else can pick my own data set and take the work that I've done and take it further? So the first step in you wanting to be a data scientist is thinking about the data, think about the business problem you want to solve and the data that connects with it. One of the other responsibilities that you have is developing some type of statistical model or statistical or predictive model that's required to run on that data set. In my own example, I wanted to know what do we humans think about voice-based assistants? And to do that, I needed to understand from a scale of 0 to 5, how do we feel, what is our level of comfort with voice-based assistants using multiple thresholds or multiple variances in terms of ways to answer that question. And after collecting that data set, I knew that I needed to start running specific statistical models. Like I wanted to test what's the eigenvalue for the data that I collected. What do I want to do? Some type of factorial analysis? Do I want to run some specific models to identify what is the perception that users truly have? How do I combine the data set, and how do I make sure that I'm removing bias and making sure that the data set that I collected is truly reliable? How do I, when I collect the data, how do I make sure that I'm removing, or if not removing, empty rows in the data or empty columns in the data? How am I running some type of buffer on that data such that I'm either using statistics to to wipe out the the blank data sets or blank sections in the data? All of those type of decisions are what I had to make to eventually create the outcomes that I was looking for in the paper. And then the last part, which every data scientist likes to see, because you do all of this work, and when you're done with the work, the next thing that you'd have to do is to present your work to your audience. Then I needed to think about visualization. How do I best visualize all of the outcomes that I've been able to come to with the data and the statistical models that I've run? So visualization is the next portion of it. All right. So this is true for AI ML, is also true for data science. The whole process of you working with your data works with this 5-step process. You want to get your data, you want to clean and prepare your data, you want to train a model or use an existing model, or train your data with a model in some cases. Then you want to test the data, asking some questions with the data, and then you want to go through that process of continuous improvement. So let's kind of go a little bit deeper into what that workflow looks like. So getting the data, as you all may know, there are multiple places where you could get the data from. If I ask the room for examples of where you could get the data from, I'm sure the top 3 answers that I'll get would include Kaggle. Kaggle has made a name for itself in terms of where you can get the data from. In some cases, there's some tools that you see out there in the marketplace, or some tools you see either in Amazon web services or in Google Cloud or even in Azure or other cloud service providers that have marketplaces where you can actually just move your data into some type of data warehouse. So there are also, the government also provides ways for you to go get your data. So you can always get your data from like government sources. I know the United States government provide data sets around specific topics. It could be infrastructure projects, data sets that could help the community go tap into that data set, combine that data set with other types of data sets that exist, and try to start making meaning or solving problems that exist today or problems that we haven't actually thought about just yet. You can get machine learning data sets from Kaggle, just like I mentioned, and then other sources where you can get data sets from. You can get like cancer data, healthcare data from so many healthcare data sites. Kaggle has financial data too around like credit, accidents, uh, recoveries, and all of that. The next thing you do after you kind of get your data, some enterprise data warehouse solution will allow you the access to import, but basically the next step after identifying that data set is importing the data, cleaning the data, analyzing the data, and then manipulating the data. Manipulating the data, as I've said a few times already today, is finding additional data sets that you want to add to enrich the existing data that you've got. So ensuring that the data conversion and normalization are done. So I'll give an example. When I collected data, there are like different types of data types you could have. You could have integers. You could have an ordinal data. You could have a nominal data. You could also have like data that's in scale. If you want to visualize data, you need to ensure that all of these data types can actually be visualized. There's some data types that cannot be visualized when you're pairing them with data set types that are not compatible. So making sure that you normalize the data. If the data type should be an integer, you want to make sure you're not representing it as an alphabet, because that would all either mess up your visualization, or it could even mess up your statistical modeling. You want to have a plan for missing values. In some cases, if the missing values are very minimal, you might have to remove those missing values and record in your final report that, yes, I had to remove these missing values. There are times where the data is just so rich and you still have missing values. But in that situation, you have an opportunity to run some type of statistical tools that could help you predict what those missing values could have been. And they do a very good job at it. And those models were created by humans like you and I. And depending on the size of the data set too, you might decide to run some Python code on the data to say, hey, all right, I'm going to transform this particular column. Why? Because this column has some decimal points, or it has some alphabets, and I can explain why this column that should have numbers has alphabets. So I'm going to remove the alphabets, and you can run some Python code to remove the alphabets from all the rows and populate the next column that you may have on there. The next step in your data science journey, or even when you're doing AI ML projects, would be to apply and train the model. When you're training models, there are multiple types of models that you could implement. You could have a regression model. You could do some type of dimension reduction. You could do some type of clustering, or you could do some type of deep learning on the data. So depending on the type of problem that you're trying to solve for, you could decide to run any of this type of models. The scope of our conversation today goes beyond, discussing models is kind of outside of the scope of our conversation today, but I'm happy to answer any specific questions that you all have with regards to models. And then making predictions. I've had the privilege of sitting on many Hamoye presentations that you all have given, and some of you all have tried to solve some problems like traffic. When is the best time to leave your house if you live in this specific region of the world? And you can start making predictions and saying that, okay, from the data that I've collected, from the model that I've run on the data, I can make this inference by saying that the best time to leave your house, if you're leaving from Victoria Island to Ikeja, or if you're leaving from Irving to Frisco, is 5 p.m. Why? Because at 5 p.m., based on what the data suggests, you have less traffic, there's less accidents. You get to define all of the variables that you want to use to make those decisions. But the business problem you want to solve always dictates what variables that you are including as you're thinking about it. Once you make your prediction, the next thing is to improve the data. A good example that I've seen in the past is I had a student in one of my data modeling class collect a data set of cancer patients. And based on the data set of cancer patients the user collected, they wanted to determine what age were a lot of people getting diagnosed for cancer. And when they got to a specific age, and I'm not going to share the age here in public, but once they got to the specific age, and the model determined that at age, I'm just going to say 50, at age 50, people are most likely have a higher chance of being diagnosed for a particular type of cancer. The next thing they decided to do was to say, okay, if it's at age 50, can we go to another world? Because this data set was collected for the United States. Can we go to Europe and go do some type of correlation? Or is it truly 50? Well, when the user collected the data for Europe, the data set suggested that it was 45. So then that became more of a different problem. If it's 50 for United States and it's 45 for Europe, and these are all arbitrary numbers, by the way, this is by no means like accurate numbers. If the data set suggests 50 for United States and 45 for Europe, can we go a step further and identify what is the difference between the type of diagnosis and the lifestyle of the users in Europe compared to the type of diagnosis and the lifestyle of the people in the US? You could use that and say, okay, I don't have enough data at that point. I need to start narrowing down to community or to zip codes so I can get the type of data that I want and ultimately improve the model or improve the inferences or add more variables to how you're thinking about solving the problem. That is how you should go about when you go about the improving process or improving path in your data science journey. So you can enrich your data set, you can enrich your data pipeline by complementing the data with multiple sources. In this case, this user or the student complemented their data set with zip code data so they can be more specific and found like anonymized data. I talked about zip code, that talks about gender, that talks about some lifestyle. Like does these people at age 50, can we do more of a focus study to identify, do they work out? Are they carnivores, or what do they eat? Like on a normal day, what's their eating style? How can we then start comparing both of them so we can come to a conclusion as to, okay, maybe the age is not 50, maybe the age is 48 based on all of these data sets. And we can do the same test. We can use Europe as like the next test to identify how do we continue to improve what we've created. You can increase the size of your data sets in some cases. I've had folks who while comparing like traffic data or accident data, they realize that we started out by identifying accident data for the whole of the US. And then we're like, maybe that's too big. We want to reduce the size or maybe increase the size in some cases. And then based on all of that, you're able to come with like actionable insights that you want to share to say, hey, here's the business problem that I want to solve. Here's what my paper is about, or here's what my study suggests. And here's what I suggest that the next person does to take the process forward. And then you can review your data sets with different lenses. One common technique that a lot of students that I've spoken to in the past would do is they try a model. There are some models that are very good at solving specific problems, but then there are newer models that have been created. Just like you have like different languages, and some languages help you speak to specific topics better than the other. There are times where there's some models that are very good at solving for particular problems, and then there are other models that are so good at solving for newer problems with a different lens on the older problem that has an established model for, that you have an established model for. So trying out new models can also be another way for you to change the problem statement or look at the problem statement with a different lens. Basically, those are like the four key steps. I mean, I added the fifth step, which is improve, but those are like the 5 key steps that I would recommend that you all kind of go through and think about at a high level as to how you look through your data, so try to solve your data science problems. But one of the topics that I am very passionate about is the topic of diversity in data science. Before I go into the topic of diversity in data science, I want to ask, are there like any pressing questions from like the last few slides that I've covered? Elizabeth there? And I'm going to look through the questions in the chat just to make sure that I respond to some of the questions before we go on here. Let's see.
Yeah, do you want to take some questions now?
No, I want to see if there are any immediate questions that I saw the screen kept moving. So I'm just trying to understand if there's like any question that has been asked that I need to attend to now before I move on to this section.
Okay, I don't really think that I've also looked through. I don't think there are any questions that need your attention right now.
Okay, very good.
Yeah, you can continue. Thank you. Oh, okay. There is one asking a question, but I think this can be answered when you're done. I don't want a situation whereby you won't be able to say everything you need to say.
Okay, sounds good.
Yeah,
all right. Well, I'll spend 3 to 4 minutes talking about diversity in data science. I want you all to know that in your data science projects, you could use Ariba models. You could use XYZ models. A lot of these models are named after people like that have names like you and I. There could even be a Susie model or a Janet model. There could be a bunch of models like that. How are these models created? Well, the first thing first, the user would have data. They will understand there's a problem that exists, and they would write code to determine, or this engineer, this data engineer, data scientist will write code to say, when I see data, here are all of the possible data types or rows or columns that I want to consider. When I see these columns, here are some of the decisions that I want to make against these columns. A lot of the technologies that we work with today, technologies like, I'll give an example. If you go to some bathrooms and you put your palm by the soap dispenser because you're about to wash your hands, that soap dispenser has like a photo sensor or an IR sensor that's looking for the sense of some type of human hand that's waiting to collect the soap. Whenever it detects that there's human hand in there, it dispenses the soap. It's identifying some type of motion with a bunch of other things. A lot of times when those models are built out, they're put into some type of chip. When that chip is created, the chip just follows whoever designed that model is creating. I say this to mean that if you are part of the process of building out what those models look like, we get the opportunity to create models that are truly representative of some of the problems that we have. We know that there's malaria in all parts of the world, but it's probably more prevalent in Africa. We know that there are like some bad roads in some parts of the world, but maybe there are like ways to navigate bad roads. Whoever that's creating models that helps identify bad roads or potholes on the road, if the person lives here where I rarely see a ton of potholes, the person may not be able to visualize or know how to solve for problems that exist in a country where they're not living in. So they will have to either exclude it, collaborate with others who are in that country, or just make an assumption. I would argue that if we have more data scientists coming out from Africa or coming out from other parts of the continent like India, we have an opportunity to insert ourselves into the process of creating what the newer models look like and ensuring that the models that are created are representative of not only one angle, but all angles of the problems are being solved. It can be a controversial topic. There's actually a Netflix movie that goes a little bit deeper into how models are built out. It goes a little bit deeper as to some of the challenges that some models face. I'll give another example that might probably come to home, that might bring this home for a few of you. And I'll share the name of the movie before the end of our conversation today. Most individuals would leave school or leave university or colleges and try to get a job. In most Western worlds, when you get a job, you want to get your car, and hopefully in the next few years or months, in some cases, you want to get a home. When you go talk to your bank to get your first car, the first thing that you notice that happens is your banker will collect, or the analyst or the person you're talking to will collect a bunch of data from you. It could be your name, it could be your history, it could be your mother's maiden name, it could be all of the addresses that you lived, it could be your earning, how much salary have you made, it could be like, what did you make the year before. It could be all of these data sets are being imputed into a model. Can you imagine if the model that it's been imputed into is a model that was created for people who live in Switzerland or people who live in the UK, but you live in Nairobi, Kenya, or you live in or your state. There has to be some type of bias that would have come into play. Like if you say that this is my first job and I'm only earning $5, the model can say based on what I know and based on the fact that rent is X% of earning, this person could only or should be only be able to afford a Toyota Corolla, or maybe you wanted something better. Again, it goes back to the person who built out the model, not for the fault of their own. The person who built out the model may not have a full idea or full picture of what salaries look like in your country, may not have a full picture of what are some of the socioeconomic conditions of your country, may not have the full idea of some of the decisions that only you know. And that's why it's ultra important for us to have more representation and more diversity in the field of data science so we can start to shape what models truly mean. So it doesn't seem like we are not part of the process. So I encourage you all as my closing remark on this diversity topic, because we can go all day. There's so many examples. I encourage you all to immerse yourself in it. I would argue that there are two fields in the future that will fundamentally change what the world that we live in looks like many years from now, and that's data science and cybersecurity. And if you find yourself in this field, embrace it and see that there's going to be very many opportunities for you to write your name in the history book. So I'm gonna take, I know that was like a 4 minute portion of my conversation, but I really hope that you all understand the gravity of and the reason why you need to embrace data science and find your own niche.
All right, thank you so much, Biodun. That was a very good one. Thank you. I hope everyone also like gained a lot from that. Thank you so much. All right.
I actually have like a final section, if you don't mind. I still have one more.
Oh, you still have...
No,
Oh.
this is just like I wanted to talk about diversity, but I have some additional thoughts. So I know that in the journey of mastery, there are many steps for a lot of us. You go through the apprentice phase, and then once you're an apprentice is what you're doing right here with Hamuye, taking projects, working with cohorts, learning from different people. But when you go through this apprentice phase, you get to understand, what am I truly good at? And where you're good at, continue to grow in it. Within the field of data science, find projects that connect with you. If, for example, I am very passionate about data science, I'm extremely passionate about cybersecurity, and I look for opportunities to have conversations in that field. There are some that are very passionate about financial equity, just making sure that everybody knows, or financial literacy, making sure that everybody understands what's available to them from a finance perspective. So find what the projects that apply to you, that connects with you the most, and continue to create your own niche in them. It could be one or it could be many. Always look for opportunities to partner with other data scientists. It could be in your current project that within Amoye, or it could be within other areas of other parts of the world. You could just find community of data scientists where you can get to learn from, because knowledge can only be incremental. Knowledge doesn't stop at one place. When you write your project, ensure you blog about it. Write a blog about your project. So if you concluded a project around credit risk score in Nairobi or in Lagos or in Chennai, come up with a blog, write about your process, talk about the people you work with, talk about what you learn, talk about what's coming next. When you do that, you're beginning to carve a niche for yourself. That's how you're going to be discovered by, who knows, maybe your next employer or your next contractor. And don't underestimate the power of a great visualization. There's so many tools that are out there, free tools that are open source tools that are out there that you could use to create excellent visualization for the data or for the project that you're working on. And wherever possible, try to use the latest technology. That is what's going to keep you relevant. You know, about a year or so ago, Google announced Vertex AI, a full workbench around creating AI ML models, and also taking that further, because you're in an ecosystem of a cloud, you can do visualizations as well using that same ecosystem. So find like the latest and greatest tools. Find that one that you really want to use and continue to build on it. That's how you create a niche for yourself. So at this juncture, I have completed my presentation. So you can take it back.
All right. Thank you so much. Thank you once again. All right. I'm sure everyone in attendance has learned a lot too. So we're going to go over to some of our questions now. But before then, the second attendance form will be dropping, and the secret code is CubeFlow, all lowercase. CubeFlow, KUBEFLOW, no gaps in between, no space in between. So they'll be dropping on YouTube, Zoom, and Slack. Just check all those platforms for the new form. All right, Daniel, over to you.
All right, thank you, Meshi. Hello, everyone. I'm sure that we have learned a lot from today's session. So I'm sure you have all posted your questions on Slido or YouTube, and I'm going to be reading the questions for Biodun now, so that I can be taking them one by one. Okay, come in. All right. So the first question I have here is from Ibukun Inri from Zoom. She said, I learned that histogram is used in descriptive statistics to visualize the frequency of numerical data. Can you explain how histogram is not used for statistical data analysis in the context of the question? I think this is referring to the question you asked initially.
That's very funny. Like we have competitive people here. You want to know why the answer is not histogram and why it's ANOVA, or I can't remember the next logistical regression. So to answer your question, histogram really is used to visualize the data. When you're running ANOVA on your data, ANOVA is more of a model that you are running on the data. You are crunching the data. You are creating new rows or columns, or you're creating new types of inferences from the data. So a histogram, however, is used to visualize the data. Histogram can be used in your data science pipeline, but it's in the visualization part. From the modeling perspective, you use statistical tools. So do not see histogram as a statistical tool, because it's not. It is more of a visualization tool.
I hope that is a very good answer for you. Slido we have, is it better to specialize on one or two data science tools, or we should try to perfect our skills in as many as possible?
It's a good question too. The way I'll answer this is, I talked about finding what you are good at, but most importantly, when you find what you're good at, make sure that there is some form of relevance in the industry. What I try to do is the way I would like for you to think about it is understand the tools that are relevant for data science. And there are quite a few of them. say for example, you decide to be more on the software side. Python is like a universal tool that a lot of folks who are in data science will want to use. Identify the tool that most folks in the industry I see as a standard and pick that. There's no true value in picking a tool that's not widely used, because then you find it, put yourself in a situation where either that tool is too old or it's not being fully adopted. So to answer your question, find the tool that's most relevant is probably my first response. If you have the bandwidth to take more than one tool, have two tools that you're going to lead with. Learning as many tools as possible may put you in the category of being a master at nothing but a jack of all. I would rather you pick one that you're really good at, such that you're able to, when you hear questions from the field or from the industry, you're able to take that and apply your deep learning on that one or two tools that you understand to solve them, other than knowing five and always struggling to identify how you want to truly solve for your problems, for the data science problems you encounter.
Mm. Thank you. Okay, next we have, can I be a business analyst after becoming a data scientist? Like giving suggestion on business. I think that's all the question right today. This from Abdul.
You can. A lot of folks who are business analysts, so data science is that umbrella that has like multiple other roles that can fall under it. Yes, you can be a business analyst after you start your career in data science. But yes, you can be a business analyst. You can use your domain knowledge or your understanding of various different business workflows to analyze problems. The answer to your question is yes.
Thank you. The next one I have here is, how much visualization is enough?
Well, you can learn visualization, but I mean, you can. So I mentioned the concept of being an apprentice to a master. There are some things that come natural to some people. When you're an apprentice, you can see visualization as just creating pie charts, bar charts, histograms, scatter plots, box plots. But then when you become a master, you've seen all of these plots. You see the problem, and you're like, you know what would be really good for this type of you know what would be really good to solve this specific business problem? It's a scatter plot, and I'll show you why. And you draw the scatter plot, and you understand what the scatter plot does, and you can explain and solve the problem for your end users. So how much visualization is too much? It's never enough. It's all about understanding what purpose is each visualization for. You can create 7 visualizations, but it makes no meaning if you don't truly understand the problem you're trying to solve and how each visualization solves for it. I was meeting with one of my directs about 2 weeks ago. We wanted to show a specific data set to our senior leaders. And I was coaching him that here's what you need to do. We can put this in a pie chart, and this is what it would look like. Because when people look at the pie chart, you sometimes don't even have to speak, because everybody understands the problem that's showing in front of them, because we picked the right one. I selected a pie chart, but then he spent 2 weeks and came back to me and said, you know what, Bio, the answer is not a pie chart. We need a bar chart. And he showed me the bar chart that he came up with, and it clicked. And he demonstrated this to our senior leaders, and the problem clicked. That right there is understanding. It's all about the more you spend understanding the problem, the more you spend understanding the visualization tools that are in front of you, the better you're able to place specific visualization to solve for specific problems. So it all comes with the journey of from being an apprentice to being a master. At the point of being a master, you know all of the problems visualization tools solve, and you know which ones aligns with.
Thank you. Next that I have here is what is the name of the data model movies on Netflix?
Oh yeah, so the one that I want you all to, I highly recommend. All right, I've watched this twice already because it's very inspiring. It's called Coded Bias. And I put the name in the chat. The movie is called Coded Bias. Go watch it, and I'm hoping that it would inspire you all to understand how important you can all be in the future of this world. Because data is like the new crude oil for Nigeria, and data is like the new gold for a lot of people. It's like the new currency. Some people have the data, but they don't know what to do with it. But they need people like you to understand how to fix the data and to understand how to create models that can better interpret the data as well. So Coded Bias is the name of the movie. Go watch it. And yeah, hopefully you can write a blog about it too.
Also, we have from YouTube, how do I cross to data science role from the economist role? The job market thinks I am downgrading since I have experience in economics.
Well, I showed a diagram or a chart, like the three circles that has data science in front of it. If you're in if your current area of specialization is economics, my recommendation to you is see yourself as your domain specialization is economics, and try to pick one of the other diagrams that I put here. 1 second. Let me try to. So your domain, and if you still have the slide, I'm happy to share. If you don't have the slide, I'm happy to share the slide after the conversation. So your domain of business knowledge is economics. And there's so many economics problems that needs to be solved, like how much loans should Africa truly be getting? Or like what kind of government policies should truly be working for Africa? You know, I was watching the news a few days ago, and I heard that in Ghana, Ghana says that they're no longer going to be buying crude oil with dollars. They're going to be buying crude oil with gold. And gold is local to them. So if you all haven't heard that, that's like how data science can make impact to an economy. Like they've studied the data, they've seen the fluctuation of currency. They understand how converting one currency and being too slow to change it back to another currency can lead to like losing money. And now you're making sense out of it. I'm saying this to encourage you that yes, you may think today that I'm an economics major, I may not have a space in data science, but look at what you do. Look at all of the areas of economics that you can make an impact if you can find the right data, understand the right data, and have an opinion that's backed by data to contribute to your economy or to any company or organization.
Thank you for that answer. Next that I have here is, please, can you throw more light on the differences between regression and correlation?
Okay, so that's a loaded question because I don't know what part of regression or correlation that you want to, you want to find out, but maybe we could share, I could share a link with you all so you could, because I need to get specifics before I could talk all and on regression and correlation, but there are key differences between regression and correlation, but I could share content. Oh, somebody is asking me how much do I earn as a data scientist? Okay. Yeah, not all of these questions I can answer on while we're live, but you can think about regression as, you know, taking data and trying to go as low as possible to understand how they can all be broken down into pieces. And then you can take correlation as looking at data and trying to find patterns. Like, you know, you have this block of data and another block of data and can understand, okay, how do these correlate with another one? But there are various models that exist to test for regression and to also test for correlation. It's like creating an empirical form. We can think about that as regression, and creating a type of like pattern, connecting two type of data sets, like connecting like a customer database to a shipping database, like ship address database. There are some correlations in there. That is like what you get from a correlation database, so or a correlation model.
All right, thank you. I think it's the same. I'm not sure. It says, secondly, should one run all applicable regression or classification models and then settle for the one with the best cost value or accuracy?
Yeah, the question, as your question underlines, all applicable, yes. In most cases, run all the applicable ones, but then always let your business problem that you're trying to solve dictate what is applicable. There are cases where it's only two applicable models based on like the tool that you're using. There might only be two models that is truly applicable. Let the business problem that you're trying to solve dictate the applicable model.
All right. Thank you. Please, what's your advice for those people whose domain knowledge isn't related to data science? Is it okay to self-study and try to become a data scientist, or just let it be?
Well, your domain knowledge should actually never be data science. Your domain knowledge should be your domain knowledge, because that's like your X factor. That's what differentiates you. Some people's domain knowledge is physics. Some people's domain knowledge is fine art. Some people's domain knowledge is archaeology. It could be anything. Your domain knowledge should not be data science, and you shouldn't even aspire to let your domain knowledge be data science. Because your domain knowledge is what's going to let you say, hey, range, if you are like in the if you're like in the crude oil business, your domain knowledge is what's going to let you look at data and look at the data from a different lens than any other person is looking at it. Why? Because you're seeing things that a fine art student would not see, or a fine art degree holder would not see, or a business degree holder would not see, because you have a unique domain knowledge. Let data science be your more of your inflection point. Be that area where you continue to learn and grow, where you understand how data works, how cleaning data works, how training data works, how modeling data, how it works, how visualizing data works, specific to your domain knowledge, and use your domain knowledge to interpret. Because the understanding is that you already have some type of knowledge today, and you now want to put a data science lens on that domain knowledge you already have.
Okay. I would like to ask you if you are still okay with taking more questions, or how many more questions do you think you can take?
Let's take like 3 more. And
okay, 3 more. 3 more. All right. Okay, the next one now is, would learning R along with Python give me an easy edge as a data scientist?
Yeah, the two languages in my opinion, again, this is my opinion, the two languages for data science, especially when you're starting, is Python and R. Would R give you an edge? 100%.
R will give an edge.
Yes. But Python should be your base. Then you can put R on top of it.
Oh, all right. Thank you. Is mathematics knowledge necessary to become a good data scientist?
I wish I would say the answer is no, but you need to understand some maths. Although, you, depending on the angle that the specialization you want to go into, some people just want to be visualization specialists. Show me the data, I'll look at the data, I'll understand it a little bit more, and I'll create the right visualization. In that type of situation, you need little math knowledge. But if you want to do more coding, or you want to create your own models, or you want to do more AI ML, knowledge of math will really take you far.
All right, thank you. Okay, I think the last one then. There are just two left actually, but like I'm just going to try to merge them into one because they seem kind of similar. Can you please advise on the role of data scientists for someone who is not from an engineering background? Is it the same as machine learning? And then there is the one that says, how do people from hybrid fields find what they are good at in data science? Like people from biology and other non-tech fields.
Yeah, I mean, this question is very similar to the economics question as well. The first question you asked is like, can you go over the first question again?
Okay, it says, can you please advise on the role of a data scientist for someone who is not from an engineering background? Is it the same as machine learning? That's how the question goes.
Okay, so you don't have to be from an engineering background. It helps when it comes to like, oh, you have some coding experience, but anybody can learn coding. I have friends who came from like a political science background and now they do some coding. YouTube has like tons of information that can help you be an expert at coding. I would also argue that you don't have that, a lot of technology can be taught. It's really what's most important is your ability to, or your passion to want to learn it. There's nothing that you cannot learn. And even people who find themselves in like engineering degrees and all of that, some tend to go back. So there are some who are engineers and become other fields outside of engineering. I would not be dissuaded if I were you, if you don't have an engineering background. There's always various areas for you to specialize in the field of data science. Machine learning is just one of them. Running AI ML models, running AI models and finding data or passing your data through AI is another section of it. Just like you buy. I'll give an example of an experience that I have when I buy an item on Amazon. I can have my Alexa device tell me that, oh, you bought this item. This item typically lasts for 60 days. You should be due for a refill by now. Are you ready for your refill? That right there does not need any smart logic. It's just common sense. So I really would like for you all to not have the misconception that you have to be any smarter than the way you are today to be in data science. There's always a niche for you. And it goes back to the biology questions. I remember in my biology classes, we were studying about cells and human cells and blood types and all of those type of things. That right there are data sets. And you can apply your knowledge of biology to data as well. You can say that when a tissue has this dot or has more than 3 dots, show me the data. How can I make a prediction that you need 2 dots to have this disease, or you need 1 dot to say that you are now immune from this disease? Like, there are a bunch of lens that you can take. See your domain knowledge as a strength and not a limiting factor. It makes me feel like I feel like I'm sounding like a motivational speaker, but honestly, I am not. But I don't want you all to look at your domain knowledge as limiting you. See it as like a way for you to actually be unique in the industry, and focus on like what you are learning from preparing data to training data. Focus on those and then use your domain knowledge as like your niche. Hopefully you are passionate about your domain knowledge.
Thank you very much, Biodun. I don't know if there is. Okay, thank you.
Yes, I want to actually answer the question how much you earn as a data scientist, because I mean, I know there's a reason why the person asked. Some people's motivation for a career can be money, and it's not a bad thing. And honestly, I want to state that it's not a bad thing. And I'm actually happy that some people are motivated by money. Some people's reason for a career can be motivated by just wanting to make a difference in the world. But sometimes you need to meet your desire for money, however big or however small, before you keep moving on that, like Maslow's hierarchy of needs. You can earn so much money as a data scientist. My primary role is not a data scientist, so I can't tell you how much I make, but I can tell you that I know that there are data scientists that can make up to $500,000, $700,000 in a year. So maybe my question to you is, what would you do with that type of money?
Thank you very much. I think Mercy, is Mercy there?
Yeah, I'm here. Thank you so much, Biodun, for even attempting to answer that question about how much you earn. That was very.
It's not how much I earn, by the way. It's not how much
I think the person was directing it at you particularly.
Yeah,
I'm not
yeah,
sure.
again, I am not a data scientist. Like that's not my primary role. I lead a team of data scientists. So there's a site that's called levels.fyi. You can see how much people projected people's projected earnings on there. So
Levels.fyi.
yes, I put that in the chat window.
All right. Okay. Thank you very much. I want to ask if you would be able to make the slide available because people are asking that question.
Yes, absolutely. I'll make the slide available to you all.
All right. Thank you so much for everything. That was really a good one. We've officially come to the end of today's webinar, and I want to thank Biodun Awojobi for taking the time to educate us today. Every second has been totally worth it. I also want to thank you, our dear interns and visitors, for joining us today. I'm certain you've gained some valuable insights and knowledge. A big thank you as well to the Amoye team and everyone who saw to the success of this webinar. So thank you so much once again, Biodun. We would be having you over another time. It's been a very insightful session with you. And until next time, everyone, have a lovely weekend. Thank you so much. And this is the end of the technical session.
All right, thank you. I hope you all have a great rest of the weekend.
Yeah, well, thanks.